Here's what will blow your mind right now, before we even start. The universe is so incomprehensibly vast that while you're watching this video, light that left the sun 8 minutes ago is hitting your eyes. But that same sunlight has been traveling through the absolute vacuum of space completely. Nothing, empty, void untouched by anything. Think of it like this. The space between you and the sun is so empty that there's barely anything there at all. Yet somehow, that light still found you. Now here's the shocking part that challenges everything you thought you knew about being alive. Somewhere right now, as I'm talking, there's a star dying in a way so beautiful and catastrophic that it's been burning for millions of years. And when it finally collapses, it will briefly outshine its entire galaxy billions of stars for just a few seconds. And here's what's relaxing about that. You don't have to worry about it. Not one bit. Because it's happening so far away that by the time its light reaches Earth, the star will have already been dead for thousands of years. But before we dive into the cosmic lullaby waiting for you, Primeta needs you to do me 3 things. First, if you're watching this because you're struggling to sleep, or you just want to feel small and peaceful in the best way possible, hit that subscribe button. We're building a community of people who find comfort in the cosmos, and every subscription tells YouTube that content like this matters. Second, I genuinely want to know, where are you watching from right now? Drop your country and your local time in the comments. Are you lying in bed in Tokyo at 2 a.m., sitting on a beach in Brazil at sunset, watching from London at midnight? Tell me! We're all under the same sky, even when we can't see it. Third, tap that like button if you believe the universe is trying to comfort you, not scare you, because by the time we finish this journey together, you're going to understand that the vastness of space isn't something to fear. It's something that makes you feel held. Let's start with something that sounds like fantasy but is completely, verifiably real. When you look up at the night sky assuming you can see it from where you other stars you're seeing aren't actually there right now. Think of it like this. Imagine sending a letter to a friend, and it takes 10 years to arrive. When they open it, they're reading words you wrote a decade ago. You're not that person anymore. You've changed. You've lived. The light from stars works exactly the same way. Proxima Centauri, our nearest star neighbor besides the sun, is 4.24 light-years away. That means the light you're seeing from it tonight left that star in 2021. It's been traveling through absolutely nothing for 4.25 years just to reach your eyes. The star you're looking at is a ghost memory of what was. Now, before you feel sad about that, here's the mind-blowing part. This means you're literally looking at the past. Every time you stargaze, you're a time traveler. You're receiving ancient light. This was first understood through rigorous observation. In 1676, a Danish astronomer named Ole Rachmer was studying Jupiter's moon Io, watching it emerge from behind Jupiter like clockwork. But something strange happened. Sometimes Io's timing was off, sometimes it appeared slightly delayed. He didn't have a telescope good enough to see what we can see today, but his mind made the leap. He realized light must travel at a finite speed. He calculated it, and though his number was roughly 27% too high, he proved something revolutionary. Light isn't instantaneous. It travels. It takes time. And from that moment on, humanity understood that when we look up, we're looking at history books written in light. Here's something calming about that. All the light reaching you right now has already survived its entire journey. Nothing destroyed it. It made it all. That weight you through trillions of miles of emptiness just to reach your eyes. That's not terrifying, that's a promise. That light has already survived the hardest part of its journey. What's actually happening when you look at the Andromeda Galaxy, the closest major galaxy to ours, visible to the naked eye in the northern hemispheres? You're seeing light that left that galaxy 2.5 million years ago. Your ancestors didn't even exist when that light started its journey. Homo sapiens weren't on Earth yet. And now, in this moment, you get to catch it. You get to hold it in your eyes. That light has been preserved, untouched, traveling through the frozen darkness for longer than human civilization has existed. and it chose to reach you. This is the first of our mind-blown moments. Just let that sink in as you're lying there. The photons hitting your retinas tonight have been traveling since before you existed. They're old, they're patient, they're peaceful. Retention hook. In the next section, we're going to discover something even more unsettling and beautiful, that the universe is getting colder, darker, and more lonely with every passing moment. And somehow, that's the most relaxing thing about it. What if I told you that the universe is literally stretching? Not like a rubber band being pulled by hands at each end, but stretching in a way that nothing, not even light, not even the fabric of reality itself, can travel fast enough to catch up with. That the universe is expanding so fast in some places that if an alien civilization 100 billion light-years away tried to send us a message, we'd never receive it, because space itself is growing faster than light can cross it. This isn't speculation. This is measured reality. In 1929, a man named Edwin Hubble did something at Mount Wilson Observatory in California that changed everything. He measured the light from distant galaxies and noticed something shocking. They weren't staying still. They were moving away from us. Not just moving, they were accelerating away, moving faster the farther they were from us. Imagine standing in the middle of a party where everyone's running away from you, and the farther they go, the faster they run. That's the universe. Hubble didn't just see this once. He measured it, he gathered data. And the pattern held. We live in an expanding universe. And here's what gets even stranger. Hubble himself didn't believe his own discovery. He thought it had to be some error. That's how shocking this was. Then in 1998, two different teams of astronomers led by Saul Perlmutter and Adam Rees made an even more stunning discovery. They were measuring how fast the universe was expanding by looking at something called Type Ia supernova stellar explosions, so bright that a single one can outshine an entire galaxy of billions of stars. What they found absolutely changed cosmology. The expansion of the universe isn't slowing down. It's speeding up. Think of it like this. Imagine throwing a ball straight up in the air. Normally, gravity slows it down. It goes up, reaches a peak, and comes back down. But what if, instead, the ball kept going faster and faster the higher it went? That's what's happening to the universe. There's some force, we call it dark energy, Mach up 68% of all the stuff in the universe, and we barely understand it, and it's pushing everything apart. Now, here's where it gets relaxing. If the universe is stretching, that means everything is getting farther apart. Galaxies that are separated from us by billions of light-years are moving away, so fast that their light is getting shifted toward the red end of the spectrum, a phenomenon called redshift. One day, maybe trillions of years from now, those galaxies will be so far away that their light will be so redshifted it will become invisible. Their light will be stretched so thin that we won't be able to detect it anymore. They'll disappear from view. But here's the beautiful part. That means the universe is slowly, gently emptying out. Galaxies are spreading out. The density of matter is decreasing. The universe had a beginning, the Big Bang, where everything was crammed into an infinitely small space, infinitely hot, infinitely chaotic. But now, 14 billion years later, it's expanded so much that it's becoming more calm, more spread out, more peaceful. The cosmic background radiation, the leftover heat from the Big Bang that was discovered by Arno Penzias and Robert Wilson in 1965, accidentally, while trying to tune an antenna, is slowly cooling down. When the universe was born, it was unimaginably hot. Now it's about 2.7 Kelvin, above absolute zero. It's being stretched so thin and so wide that all the heat is being distributed across trillions of cubic light-years of emptiness. It's cooling down. It's calming down. We're living in a universe that's settling down. Think of it like this. Imagine you're in a room after a party. The party was chaotic, people everywhere. Noise, heat, but people are leaving. The room is emptying out. The temperature is dropping. The noise is fading. In a few hours, the room will be empty, quiet, cold, and peaceful. That's the universe. It's on a billions of years long journey toward perfect quietude. Here's the second mind-blown moment. The ultimate fate of the universe might be heat death, a state so quiet, so calm, so perfectly balanced that nothing will ever happen again. No stars will shine. No planets will orbit. No life will exist. Just cold, empty darkness, stretching forever. And somehow, when you really sit with that, when you let yourself feel small in a universe so vast and so old, it stops feeling terrifying. It feels like being gently lowered into a comfortable darkness. The universe is drifting towards sleep, and you're part of it. You're made of the same particles that started as chaos and are now spreading out into peace. Your atoms will eventually cool. Everything will cool. The universe is the most patient thing that exists, and it's teaching you right now, through this realization, let go, spread out, cool down, rest, retention, hook. But wait before the universe gets to that peaceful, empty end. There's something utterly mind-bending happening right now. Stars are being born and dying in patterns so regular, so rhythmic, that they're like the universe's heartbeat. And that's what we're exploring next. What if I told you that right now, as you're listening to this, there's a star collapsing somewhere in the universe? Its core is being crushed by gravity so intense that nothing can stop it. Electrons are being forced into protons. The fundamental forces of nature are being violated. And in the last second of that star's existence, it releases more energy than the sun will release in its entire 10 billion year lifetime. That's not metaphor. That's not exaggeration. That's an actual supernova. And there are about 100 of them every single second in the observable universe. 100 stellar explosions per second. Right now. This second. And the next one. Most of those supernovae are so far away that we'll never know about them. Their light is traveling toward us right now, but it will take millions of years to reach us. And when it does, the star will have been dead for millions of years already. We'll be looking at a grave marker made of light. But here's the relaxing part. Stars are supposed to die. Stars are not permanent. Nothing is permanent. And that's okay. For about 10 billion years, and our sun is currently about 4.6 billion years old, roughly 46% through its life, a star spends its main sequence in a state of perfect balance. Think of it like this. The star is like someone in meditation. The force of gravity is trying to crush everything toward the center, but the heat generated by nuclear fusion in the core is pushing back, outward. These two forces, inward and outward, are in perfect equilibrium. They balance each other so completely that the star hangs there, burning steadily for billions of years. This balance is one of the most profound things about existence. It's the reason you're alive. Your star, the sun, is so perfectly balanced that it can provide consistent energy for billions of years. That stability allowed complex life to evolve on Earth. But let's talk about what happens when a star runs out of fuel. This is where it gets truly beautiful. In 1930, a physicist named Subrahmanyan Chandrasekhar made a discovery that sounds abstract, but is actually profound. He calculated that a star heavier than 1.4 times the mass of our Suna limit, now called the Chandrasekhar limit, cannot become a white dwarf when it dies. If it's that heavy, when it collapses at the end of its life, gravity will overcome even the quantum mechanical forces that normally hold matter apart. What happens is this. The star collapses. Its core is crushed inward, and then, and this is the moment of cosmic catharsis, it rebounds. It bounces back. The sudden collision of material falling inward creates a shock wave. Temperatures spike to billions of degrees. Nuclear fusion ignites in the rebounding material, and the star explodes outward in what we call a supernova. In that single explosion, more light is released than our sun will release in its entire existence. And here's what's beautiful. From that explosion, elements are created. Carbon, oxygen, silicon, iron, the building blocks of planets, life, and you. Literally you. The iron in your blood was forged in the core of a dying star. The calcium in your bones was created in a stellar explosion. You're made of stardust in the literal, scientific sense. One study from 2009, led by astrophysicist Jane Greaves, specifically traced the origin of complex elements in Earth's crust and found that roughly half came from supernova explosions. That means supernova shockwaves seeded our solar system. Think about that as you're lying there. The violent death of stars is what made your existence possible. Stars didn't just have to exist. They had to die in violent explosions that scattered elements across light years of space. Those elements eventually coalesced into planets. One of those planets was Earth. On Earth, chemistry became biology. Biology became consciousness. And Ere made entirely of stellar debris, thinking about stars. The rhythm of the universe isn't random. Stars are born, they burn steadily for billions of years, they die spectacularly, and from their death comes new material for new stars, new planets, new life. It's a cycle. It's a pattern. It's like a heartbeat that repeats across billions of years. And you're inside that rhythm right now, your own atoms participating in a cycle that's been going on since the first stars ignited. Here's the third mind-blown moment. You don't need to be afraid of the death of stars, because you're made of their death. You're not separate from the cycle, you're part of it. And cycles are peaceful. They're predictable. They're eternal. Retention hook. But here's something even more soothing. While these dramatic cosmic events are happening across incomprehensible distances, right here, in our own cosmic neighborhood, there's something so stable, so reliable, so utterly predictable, that it might be the most comforting object in the universe. We're talking about next. Imagine living for 1,000,000 years. Imagine seeing 1,000,000 sunrises, 1,000,000 sunsets, the sun rising every 24 hours, like clockwork, never missing once. Imagine knowing with absolute certainty that tomorrow the sun will rise in the east and set in the west, exactly as it did today. Imagine this not for 1,000,000 years, but for 4.5 billion years. That's the stability you're bathed in right now. That's the gift the sun represents. In 1610, Galileo Galilei pointed his telescope at the sun and made a discovery that changed how we see our star. He saw spots on the surface, dark regions that appeared and disappeared. He realized the sun itself was changing, moving, rotating. It wasn't the immutable, perfect sphere that ancient astronomers had thought. It was dynamic, alive, complex. For the next 300 years, astronomers carefully tracked sunspots. They counted them. They measured their movement. And in 1844, a German scientist named Samuel Heinrich Schwab announced something shocking. The number of sunspots follows a pattern. Every 11 years, the sunspot activity peaks, then drops, then peaks again. An 11-year cycle. This became known as the solar cycle, and it's one of the most reliable patterns in the universe. It's so regular that we can predict solar activity with remarkable accuracy. You could know, right now, that in March of 2027, the sun will be close to peak activity in its current 11-year cycle. You could tell someone in 2050 roughly what solar activity will be like, and you'd be right. Think of it like this. Your own body has rhythms. Your heartbeat, your sleep cycle, your circadian rhythm. These patterns are calming because they're predictable. The sun has a rhythm too. The entire star is breathing, in a sense, with an 11-year cycle. But here's what's even more stable than the 11-year cycle. The sun's fundamental process. Deep in its core, at temperatures of 27 million degrees Fahrenheit, hydrogen nuclei are being forced together to create helium. This is nuclear fusion. It's been happening for 4.6 billion years. It will continue happening for another 5 billion years. Every second, the sun converts 620 million tons of hydrogen into helium. Every second, for billions of years. The output is so consistent that the amount of energy Earth receives from the sun varies by less than 1% from year to year. Less than 1% in the context of the entire universe. That's like having a lamp in your bedroom with a switch that has exactly 2 positions, on and still on, just imperceptibly slightly dimmer. This constancy is what makes life possible. For billions of years, Earth has orbited in what we call the habitable zone, the region around a star where liquid water can exist on a planetary surface. Not too hot, not too cold. Perfect balance. And the sun has maintained this perfect balance for long enough that life didn't just begin. It evolved diversified, and became conscious. You're alive because a star 93 million miles away is predictably, almost mechanically, converting hydrogen to helium with astounding consistency. The sun is like the universe's most reliable clock, and you're running synchronously with it. As you're lying there, your own body is warm because of the sun's stable energy. Your own metabolism is powered by the sun's ancient energy, captured billions of years ago by the first plants and stored in molecules. Your thoughts right now are electrical impulses traveling through your brain, powered by ATP molecules that were ultimately powered by the sun. The sun is the baseline. It's the constant. In a universe of chaos, expansion, dying stars, and cosmic violence, there is the sun, reliable, patient, consistent, burning steadily in the darkness. The fourth mind-blown moment, you are literally powered by the most consistent object you'll ever encounter. The sun will probably outlive you by billions of years. And right now, as you're listening to this, it's maintaining the exact energy output that keeps you alive. That's not a coincidence. That's a feature of reality. Some things are stable. Some things last. Some things can be trusted. Retention hook. So we've established that the universe is stretching, that stars are dying and being born in beautiful cycles, and that right here, in our cosmic neighborhood, we have the most stable source of energy in existence. But what happens when you zoom in? What happens at the smallest scales? That's where things get truly weird and genuinely calming. Here's something that sounds like philosophy, but is actually quantum mechanics. At the smallest scales, the scales of atoms and electrons, reality doesn't work the way you think it does. Particles don't have definite locations. They exist in a state of probability. They're in multiple places at once until you measure them. And the relaxing part, that's fundamentally how everything is, including you. In 1925, Werner Heisenberg proposed something that sounds impossible. The uncertainty principle. It says that you cannot simultaneously know both the exact position and exact momentum of a particle. The more precisely you know where it is, the less you know about how fast it's moving, and vice versa. This isn't because our instruments are bad. This is because reality is fundamentally uncertain at quantum scales. Think of it like this. Imagine trying to photograph a moving car. If you use a fast shutter speed, you get a clear picture of where the car is, but it looks frozen. You can't tell if it's moving fast or slow. If you use a slow shutter speed, you can tell the car is moving from the motion blur, but you can't exactly see where it is. You're forced to choose. And that choice exists, not because of camera limitations, but because motion and position are linked in nature. You literally cannot have perfect knowledge of both. Heisenberg's discovery was controversial. Even Albert Einstein struggled with it. But every experiment since has confirmed it. In 2012, scientists at the Vienna University of Technology performed one of the most precise tests of the uncertainty principle using entangled photons and verified that not only does it hold true, but it holds true more precisely than Heisenberg's original formulation predicted. But here's what's absolutely beautiful about quantum uncertainty. If the world were completely determined, if everything were perfectly predictable and fixed, then there would be no freedom, no possibility, no genuine novelty in the universe. But because of quantum uncertainty, the universe is genuinely open. The future isn't written. At the smallest scales, there are genuine probabilities, genuine possibilities. In 1927, Erwin Schrödinger and Niels Bohr had a famous conversation at a conference in Como, Italy. Schrödinger didn't like quantum mechanics. He didn't like the idea that particles don't have definite properties until measured. He thought it was incomplete. But Bohr argued that the measurement problem was fundamental. You cannot separate the observer from observation. The act of looking changes what you're looking at. What they were both grappling with is something profound. At the quantum level, reality is fundamentally relational. Things don't have properties independent of being measured. This sounds strange, but it's actually deeply peaceful. It means the universe isn't a machine running on predetermined rails. It means that consciousness and observation are woven into the fabric of reality. Here's what that means in practice. Electrons don't actually orbit atoms in neat circles like planets around stars. Instead, They exist in probability clouds called orbit. An electron is genuinely in a superposition of states, multiple possible configurations, simultaneously until you measure it. This is called quantum superposition. Think of it like this. Imagine you have a book, and it's simultaneously open and closed until someone looks at it. On cette look, it's definitely one or the other. That's superposition. And weirdly, that's how the world actually is. At quantum scales, now here's why this is relaxing. If the universe at the smallest scales is fundamentally uncertain, then you are fundamentally uncertain. Your atoms are in superposition. Your electrons are probability clouds. You're not a fixed, determined thing. You're a pattern of probability. You're not locked into being. Exactly what you are right now. You're genuinely open to change, growth, transformation. You're made of quantum stuff. And quantum stuff is fundamentally free. The fifth mind-blown moment. At your deepest level, you're not a fixed, mechanical thing. You're a probability wave. You're uncertain. Yo, urre, free. Ansomeo. Knowing that, not even the universe can pin you down to a single definite state, is weirdly calming. You can't be trapped. You're fundamentally capable of being different, because you're fundamentally uncertain. As you're lying there, your atoms are vibrating, existing in multiple quantum states, uncertain about their exact positions in momenta. You're made of freedom at the smallest scales. You're made of possibility. Retention hook. We've gone from the biggest scales the stretching universe do, the smallest scales quantum superposition, but there's a place in between, a scale where things get truly peaceful, the scale of planets and moons, and specifically, the scale of orbits, because orbits, it turns out, are nearly perfect circles of peace. There's a scientist named Johannes Kepler who, in the early 1600s, became obsessed with something that other astronomers had noticed but dismissed. The planets don't orbit the sun in perfect circles. They orbit in ellipses, slightly stretched circles. And Kepler wanted to know, is there a mathematical pattern? What he discovered is one of the most beautiful things in physics. Kepler's first law of planetary motion says this: planets orbit the sun in ellipses, with the sun at one focus of the ellipse. The second law says that a line from the sun to a planet sweeps out equal areas in equal times. In other words, planets move faster when they're close to the sun and slower when they're far away. And the third law, the most beautiful one, says that the square of a planet's orbital period is proportional to the cube of its average distance from the sun. Let's translate that into human language. This means that if you know how far a planet is from the sun, you can calculate exactly how long it takes to orbit. And the relationship is mathematical. Perfect. Elegant. Earth is 93 million miles from the sun, on average, and it takes exactly 365.25 days to orbit. Mercury is much closer, only 36 million miles. It orbits in just 88 days. Venus is 67 million miles away and takes 225 days. The distances and times are different, but they follow the same mathematical law. In 1687, Isaac Newton explained why. He discovered the law of universal gravitation. Every object with mass pulls on every other object with mass. The force depends on the mass and decreases with the square of the distance. Think of it like this. Gravity is like an invisible rope connecting every planet to the sun. The rope is always pulling inward, but the planets are always moving forward, like they're trying to fly off straight into space. The balance between these two forces, the pull inward and the push forward, creates an orbit. Here's what makes this absolutely beautiful. These orbits are stable. A planet that orbits the sun can, under the right conditions, continue orbiting for billions of years. The same elliptical path over and over. Earth has completed about 46 million orbits around the sun. It will complete about 55 million more before the sun dies. And every single orbit takes almost exactly the same time, 365.25 days. This precision is absolutely extraordinary. Think about this. You depend on Earth's orbit with absolute precision for your existence. If Earth's orbit were slightly different, we would either be frozen or burned to death. If Earth were closer to the sun, it would be too hot for complex life. If it were farther away, it would be too cold. But Earth is positioned in what we call the Goldilocks zone, not too hot, not too cold. And here's the beautiful part. We're not in some lucky accident. The fact that Earth's orbit keeps you in the habitable zone isn't luck. It's a consequence of physics. Orbits are stable. Planets that end up in stable orbits stay in stable orbits. The mathematics guarantees it. In 2014, NASA's Kepler Space Telescope, which discovered over 2,600 exoplanets by measuring the slight wobbles in the light of distant stars, found that thousands of those planets are in stable orbits around their stars. Some in the habitable zone. The mathematical laws that govern our solar system govern all planetary systems. It's not local, it's universal. Stable orbits are a feature of reality. Now imagine being a planet. You're hanging in space, circling a star, and the same forces that have kept you in the same orbit for billions of years will keep you in that same orbit for billions more. Your path is known. It's predictable. You're not lost or drifting randomly. You're in a precise mathematical relationship with your star, and that relationship will hold your Earth. And every single day, you wake up to the same sun, orbiting in the same ellipse, following the same laws that have governed your motion since you formed 4.5 billion years ago. The sixth, mind-blown moment. You're not floating randomly in space. You're part of a mathematically stable orbital system. Your planet's path around the sun is written in the laws of gravity, and those laws guarantee that you'll keep waking up tomorrow on a planet in the habitable zone because your planet's orbit is stable. Retention hook. So we've established that orbits are stable, precise, and mathematically perfect. But there's something even more amazing when you look at what's inside those orbits. And moons have something to teach us about the deepest kind of peace. Imagine a dance partner who dances the same dance every single night for billions of years. They face you the same way. They move in the same pattern. They never miss a step. They never change. That's the moon's relationship to Earth. It's called tidal locking, and it's one of the most profound expressions of gravity in the universe. The moon orbits Earth every 27.3 days. But here's what's less known. The moon also rotates on its axis, and it takes exactly 27.3 days to complete one rotation. The moon's orbital period equals its rotational period. This is called synchronous rotation, or tidal locking. It means the same side of the moon always faces Earth. Always. It's been this way for billions of years. This isn't a coincidence. This is a gravitational consequence. When the moon was younger and spinning faster, Earth's gravitational pull created tides in the moon's body. Those tides transferred energy from the moon's rotation into orbital motion. Over billions of years, the moon slowed down until its rotation matched its orbit. And now, the gravitational force is balanced perfectly, and the moon stays locked in that pose. In 1959, the Soviet spacecraft Luna 3 flew around the far side of the moon and sent back the first images of the side we never see. For all of human history, we'd looked up at the same lunar face, completely ignorant that there was another side. The revelation was simultaneously profound. We'd never seen 25% of our nearest cosmic neighbor because of gravitational physics. Think of it like this. Imagine dancing with someone where you both spin at exactly the right rate that you always face each other. You never see their back. They never turn away. You're locked together by the physics of your motion. That's the Earth-Moon system. But tidal locking gets even more interesting when you look at what it means. The gravitational force that the moon exerts on Earth is not uniform. The side of Earth facing the moon experiences slightly stronger gravity than the far side. This difference creates a tidal bulge. Water on the side facing the moon is pulled toward the moon slightly more strongly, creating an ocean bulge. This is why we have tides. But here's what's beautiful. Tides are not random. They happen on a schedule. The moon rises and sets. Tides come in and go out. For billions of years, life on Earth has evolved in rhythm with the tides. Early fish that ventured onto land had to survive tidal patterns. The first land animals evolved in tidal pools. Human menstrual cycles, for reasons we don't fully understand, are roughly lunar length, about 29.5 days, which is the lunar month, we are tightly locked to the moon at a deeper level than we realize. Our biology is entrained to lunar rhythms. In a study published in Science Advances in 2013, researchers found that many animals, from zooplankton to fish to mammals, have internal biological rhythms that are synchronized to the lunar cycle. We are all, in some sense, dancing with the moon. We're all following the same gravitational rhythm that locks the moon's face toward us. As you're lying there, right now, the moon is in the sky above you, or on the other side of Earth, but still exerting its gravitational pull. The moon that you're looking at, if you're in the northern hemisphere and can see it, you're the same features that humans 2,000 years ago saw, the same craters, the same dark Maria, the same mountainous highlands. Because the moon is locked with you. The moon is your eternal dance partner. And the beauty of being locked in an orbital embrace is that the dance is predictable. You know where the moon will be. You know what you'll see. The moon won't turn away. The moon won't surprise you. It will maintain the same rhythm forever until billions of years from now, when the moon slowly drifts away due to orbital decay and Earth becomes unlocked from its ancient partner. The seventh mind-blown moment, you're locked in a gravitational relationship with the moon that has held for billions of years and will hold for billions more. The moon's rhythm is your rhythm. Your tides are its tides. You're not alone out here in space. You have a dance partner. And the dance is eternal. Retention hook. So we've talked about tidal locking between Earth and the moon. But the most extreme version of tidal locking exists around black holes. And while that sounds terrifying, it's actually the gateway to understanding the deepest peace the universe can offer. Black holes are, without a doubt, the most extreme objects in the universe. They're places where gravity is so strong that nothing can escape, not light, not matter, not even time itself. The event horizon is the point of no return. Cross it, and you're gone forever. And yet, somehow, black holes are the most peaceful objects in the universe. In 1915, Albert Einstein published his general theory of relativity, which fundamentally changed how we understand gravity. Gravity isn't a force pulling things. It's the curvature of space. Massive objects bend the space around them like a bowling ball, creating a dip in a trampoline. Other objects fall into that dip. In 1916, a physicist named Carl Schwarzschild, while serving as a soldier in World War I, solved Einstein's equations for a special case. A perfectly spherical, non-rotating mass. His solution revealed something shocking. If you compress enough mass into a small enough space, you create a region where spacetime is bent so severely that escape becomes impossible. An event horizon, a boundary beyond which nothing can escape. Schwarzschild died of an illness a few months after proposing his solution. He never knew that his mathematical solution would lead to the prediction of black holes. For decades, physicists debated whether black holes were real. In 1971, astronomers observed Cygnus X1, an X-ray source that seemed to be in orbit with a visible star. The X-rays were being generated by matter falling into an invisible object so massive and so small that it had to be a black hole. For the first time, we had observational evidence. Think of it like this. Imagine a point in space where gravity is so strong that the rules change. Space and time are bent so severely that what happens inside the event horizon is literally causally disconnected from the outside universe. Cause and effect operate differently inside. And here's why black holes are peaceful. Black holes are completely predictable. Once you know the mass of a black hole, you can calculate everything about it. You can predict exactly how space-time is curved around it. You can predict the positions of stable orbits. You can predict the temperature of the event horizon. In 1974, Stephen Hawking made an astonishing discovery. Black holes aren't actually black. The intense gravity at the event horizon creates quantum effects. Virtual particles constantly appear and disappear in spacetime. At the event horizon, sometimes one particle of a virtual pair falls into the black hole while the other escapes. The escaped particle becomes real. It carries away energy, and so black holes slowly evaporate, emitting what we now call Hawking radiation. But even this is peaceful. The evaporation is slow. A stellar mass black hole, created from the collapse of a massive star would take. longer than the current age of the universe, to evaporate by a factor of trillions. It's so slow that to an external observer, it looks stable. Here's what's genuinely beautiful. Anything that falls into a black hole is trapped there. Its atoms are no longer part of the outside universe. They're part of the black hole. They've become integrated into the gravity itself. The information of what they were is preserved in the geometry of space-time around the event horizon. In a very real sense, they become eternal. De ive come parte of an object that will outlast all stars, all galaxies, and survive until the end of time. In 2023, the Event Horizon Telescope collaboration released the first image of the event horizon of a black hole at the center of the galaxy, M87. It showed a bright ring of light around a dark center, exactly what relativity predicted. The image revealed that black holes are real, and they're exactly as mathematically predictable as Einstein's equations said they would be. As you're lying there, the largest black holes are sitting at the centers of galaxies, each one the mass of billions of suns. Completely still, completely predictable, completely locked into the mathematical laws of general relativity. They're the anchors of galaxies. They're what hold galaxies together. You exist because a black hole sits at the center of our galaxy, stabilizing the orbit of the sun, which stabilizes your orbit, which keeps you alive. The eighth mind-blown moment. The most extreme objects in the universe, black holes, are also the most mathematically perfect, the most predictable, and the most stable. There's a weird comfort in that. In a universe of chaos and expansion and dying stars, black holes are islands of perfect, inevitable mathematical stability. They can be predicted to arbitrary precision. They follow the laws. They don't surprise. And in that, there's deep peace. The universe respects its own laws. It doesn't cheat. It doesn't surprise. Even at the edge of space-time, at the boundary of what's possible, the math holds. Retention hook. So we've talked about the biggest structures in the universe. Galaxies held together by black holes. But the smallest structures, quantum particles, are equally beautiful. And when you understand how the universe can be both quantum and classical at the same time, you start to see a hidden unity underneath everything. Here's the biggest unsolved mystery in physics. The universe operates by two different sets of rules. At large scales, planets, stars, galaxies, black holes. The rules are given by general relativity, Einstein's theory of gravity, and space. At small scales, atoms, electrons, photons, the rules are given by quantum mechanics. But here's the problem. The rules are incompatible. They contradict each other. And yet, the universe seems to obey both sets of rules simultaneously. This is the deepest unsolved mystery in physics, and the attempt to solve it is teaching us something profound about the structure of reality. In the 1940s and 1950s, physicists like Richard Feynman, Freeman Dyson, and Julian Schwinger worked on what's called quantum field theory. They were trying to combine quantum mechanics, which describes how particles behave, with special relativity, which describes how space and time interact. What they discovered is that at the smallest scales, particles aren't really particles at all. They're excitations in quantum fields. Think of it like this. Imagine an ocean that fills all of space. Every possible field, the electron field, the photon field, the Higgs field, is like a different layer of that ocean. Waves in these fields are what we observe as particles. But then you have gravity. Gravity doesn't work the way other forces work. Gravity is space-time itself. According to general relativity, you can't quantize space-time in the way you quantize other fields. Or at least, we don't know how. For decades, the two theories have remained incompatible. In 1995, Juan Maldacena proposed something called the ad-se-fete correspondence. It suggested a deep duality. A quantum field theory in a certain geometry could be equivalent to gravity in a higher dimensional space. It was just a conjecture, but it was profound. It suggested that quantum mechanics and gravity might not be fundamentally incompatible. They might be two different ways of describing the same thing. The beautiful thing about the quantum classical bridge is this. At the boundary between small scales and large scales, something remarkable happens. The quantum probabilities average out. The wave functions collapse. Quantum weirdness transitions into classical predictability. You exist at exactly this boundary. Your neurons are made of atoms. Your atoms are made of electrons and nuclei. Electrons are quantum objects there in superposition. They're uncertain, they're fundamentally weird, but your brain is classical. It's predictable mostly. You're conscious. You think. You make decisions. How is that possible? How can quantum weirdness become classical order? The answer is something called decoherence. At the quantum scale, objects are isolated. Electrons in atoms don't interact much with the outside world. They can maintain quantum superposition. But at the scale of your brain, things are constantly interacting. Particles are bumping into each other. Atoms are vibrating. Energy is being exchanged. In T's noisy, interactive environment, quantum superposition decays. The probabilities collapse. Order emerges. This is actually peaceful. It means that at your scale of the human scale of the universe is not quantum. It's classical, it's stable, it's predictable. Gravity works the way Newton said it does. Balls fall down. Objects stay where you put them unless you move them. Time flows from past to future. You can trust your senses. But at the smallest scales, quantum mechanics ensures that there's always freedom, always possibility, always uncertainty. The universe is woven together. Quantum freedom at the small scale, classical order at the large scale, with a smooth transition between them. The ninth, mind-blown moment. You're not trapped between two incompatible universes. You exist in the classical realm because of your atoms are constantly decohering, collapsing from quantum superposition into classical positions and velocities. The quantum realm is underneath you, but it's not affecting your experience directly. You're shielded from quantum weirdness by the very fact that you're large enough to cause As you lie there, your brain is making sense of the world through the rules of classical physics. And those rules work. They're reliable, they're predictable. And underneath, at the smallest scales, there's quantum freedom. You're made of both. You're connected to both. The universe is unified in you. We've explored the biggest scales, the smallest scales, and the boundary between them. Now it's time to bring this all home to explain how this cosmic understanding should change the way you see yourself and your life. You are made of stardust. That's not poetry. That's not metaphor. That's chemistry. The carbon in your body was forged in the core of a dying star. The oxygen was created in a stellar explosion. The iron in your blood was created in a supernova. The calcium in your bones came from stellar nucleosynthesis. You're literally made of stellar material. But here's what goes deeper. You're also made of the history of the universe. Every atom in your body is billions of years old. The carbon-12 in a carbohydrate molecule you eat might have been created 6 billion years ago in a star that exploded 5 billion years ago. It orbited in interstellar space for 1 billion years. It was incorporated into a molecular cloud. That cloud collapsed into our solar system 4.6 billion years ago. The carbon became part of the early Earth. It was incorporated into the first living organisms. It's been cycling through the biosphere ever since. And now, it's part of you. You're not separate from the cosmos. You're an expression of it. You're the universe, experiencing itself from a particular angle. Carl Sagan, a planetary scientist and astronomer who spent his career making science accessible to the public, said, "The nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of collapsing stars. We are made of We are a way for the cosmos to know itself." This isn't poetic exaggeration. This is literal truth. In 1957, Fred Hoyle and other astrophysicists proved that heavy elements can only be created in stars. The universe was born with only hydrogen, helium, and trace amounts of lithium. Every other element that makes up planets, life, and us created in stars. Think of it like this. Imagine a recipe for making a human being. The first ingredient is cosmic rays. The second ingredient is hydrogen and helium from the Big Bang. The third ingredient is stellar nucleosynthesis. You mix them together in a star, let it fuse for billions of years, then explode in a supernova and scatter those elements across light years of space. Wait 4 to 5 billion years for a planetary system to form. Let chemistry happen on the surface of one of those planets. Wait 3 to 4 billion more years for life to evolve. And eventually, you get a human being lying in bed at night, thinking about stars. This realization changes you. Once you truly internalize that you're made of stardust, that your atoms have been cycling through the universe for billions of years, that your consciousness is quite literally the universe becoming aware of itself, you start to see yourself differently. You're not insignificant. You're not alone. You're not lost in an uncaring cosmos. You're an expression of the cosmos. You're an end product of 14 billion years of cosmic evolution. Every structure in the universe, from atoms to stars to galaxies, was necessary for you to exist. The laws of physics had to be precisely tuned. Stars had to die in the right way. Planets had to orbit in the right place. Life had to evolve. And somehow, impossibly, here you are, conscious, thinking, feeling. The psychologist Carl Jung wrote about the concept of synchronicity, meaningful coincidences, but from a cosmic perspective, your existence isn't a coincidence. It's inevitable, given the laws of physics, and yet, you're also unique. There's never been another you. There's never been anyone with your exact combination of atoms, your exact pattern of connections, your exact perspective on the universe. In 1974, NASA sent the Mariner 10 spacecraft toward Jupiter, and as it passed Saturn, the brilliant astronomer Carl Sagan convinced NASA to turn the spacecraft's camera around and take a picture of Earth from 4 billion miles away. The resulting image showed Earth as a tiny, pale blue dot in the vastness of space. Sagan wrote about that image, "Look again at that. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you've ever heard of has lived their entire lives. All the generals and emperors, all the heroes and cowards, all the creators and destroyers of civilization are there, on a mote of dust suspended in a sunbeam." The perspective is humbling and empowering at the same time. The 10th mind-blown moment. You're not insignificant. You're stardust that's become conscious. You're the universe experiencing itself. You're connected to everything that's ever existed, the Big Bang, the first stars, the supernova, the planets, the first organisms, every human who's ever lived through the atoms that make up your body. And that's not scary. That's beautiful. That means you're never truly alone. You're part of a community that extends across 14 billion years and 93 billion light-years of space. You're part of something vast and eternal and beautiful. As you lie there, recognize that the atoms of your body are the same age as the universe. They've been here the whole time. They're ancient. They're peaceful. They've survived everything the universe could throw at them. And they're yours now. They're making you conscious. They're making you real. Retention hook. So we've established that you're made of the universe, that you're connected to everything, that you're part of a grand cosmic story. But there's something even more comforting. The universe has a purpose, in a sense, and that purpose includes consciousness. It includes you. Here's something that seems philosophical, but is actually based on physics. Is the universe conscious? And if not, why does it seem to be set up in such a way that consciousness inevitably emerges? In the 1970s, physicists began noticing something strange about the universe. The fundamental constants numbers, like the strength of gravity, the charge of the electron, the speed of light, seem extraordinarily fine-tuned to allow for the existence of complex structures, stars, planets, and life. For instance, the strength of gravity determines how stars burn. If gravity were just 1% stronger, stars would burn out in 1,000,000 years instead of billions. That's not enough time for life to evolve. If gravity were 1% weaker, stars wouldn't form at all. No stars, no planets, No life. The strength of the strong nuclear force, the force that holds atomic nuclei together, is similarly finely tuned. If it was slightly different, heavier elements like carbon couldn't form. Without carbon, there's no organic chemistry, no DNA, no life. Sir Fred Hoyle, the astrophysicist we mentioned before, made an astonishing calculation in 1952. He calculated the conditions needed to create carbon stars. According to his calculations, the nuclear resonance that allows carbon to form required a precise energy level, precise to within 1%. He calculated what that energy should be, and predicted that physicists would find a resonance at that exact energy. When they checked, it was there. Hoyle was so impressed by this finding that he said it was as if a superintellect has monkeyed with physics. He didn't mean that literally. He was expressing his amazement at the precision of the universe. This phenomenon is called the anthropic principle. The strong form says the universe must have properties that allow conscious life to develop within it. The weak form says we should not be surprised that the properties of the universe are compatible with our existence, because we exist. Think of it like this. Imagine you're a character in a story. You notice that the story is perfectly written for your existence. The plot moves in ways that allow you to be born. The world has the right properties for you to survive. Should you be surprised? In a way, no. If the story didn't have those properties, you wouldn't exist to notice it. The fact that you exist to ask the question means the answer must be yes, the story is compatible with you. Some physicists propose a solution to the fine-tuning problem. The multiverse. The idea is that our universe is one of perhaps infinitely many universes, each with different fundamental constants. Most of those universes would be dead, no stars, no planets, no life. But by sheer probability, some universes would have the right constants. We, by necessity, observe one of those rare universes. Because we exist, we couldn't possibly observe any other kind. This isn't unfalsifiable speculation. Some physicists like Andre Linde at Stanford have shown that inflation theory, the leading theory of the Big Bang, naturally predicts an infinite multiverse. It's a mathematical consequence of the theory. But here's what's important. Whether or not the multiverse exists, the fact remains that our universe is set up in a way that allows consciousness to emerge. The laws allow for it. The constants allow for it. The universe seems to be oriented toward consciousness. And that's beautiful. That's peaceful. That means consciousness isn't an accident. It's woven into the fabric of reality. Think about it this way. If the universe didn't care about consciousness, if consciousness were just a random accident, then it shouldn't be so difficult for consciousness to exist. But instead, consciousness is rare. Life only exists on one planet that we know of in a universe of trillions of planets. Consciousness is expensive. It takes billions of years to evolve. It takes complex structures. It requires stable conditions. And yet, the universe seems to be oriented toward producing those conditions. The laws seem fine-tuned to make consciousness possible, as if the universe, in some deep sense, is trying to know itself, as if consciousness is the universe's purpose. This is speculative, but it's not unscientific. It's the kind of thinking that comes naturally when you contemplate the structure of reality. The 11th mind-blown moment. The universe isn't hostile to consciousness. It's oriented toward it. The fundamental constants are fine-tuned to allow complex structures. Stars had to burn and die to create the elements. Planets had to form. Life had to evolve. All of it, somehow, seems to be oriented toward this moment. You, conscious, aware, thinking about the cosmos. You're not an accident. You're not a random fluke. You're an expression of the universe becoming aware of itself. And the universe seems to want that. The universe seems to be oriented toward consciousness. Retention hook. So we've established that consciousness might be central to the universe's purpose. But what does that mean for how you should live? How should you treat consciousness, your own and others, if it's the universe's highest expression? If the universe is oriented toward consciousness, if consciousness is the point toward which the entire cosmic story is aimed, then consciousness, you're Consciousness is sacred, not in a religious sense, necessarily, but in the sense that it's precious, rare, and central to the meaning of the universe. Think about what consciousness actually is. It's the ability to experience, to feel, to be aware of being aware. To witness. It's extraordinarily rare in the universe. Most things are unconscious. Rocks are unconscious. Stars are unconscious. Even the vast majority of living things, bacteria, plants, insects, might not be conscious in the way you are. Consciousness seems to be something that emerges only in complex nervous systems, in brains. And even then, it's fragile. A small change to your brain chemistry can disrupt it. Sleep deprivation damages consciousness. Brain injuries can destroy it. Disease can diminish it. And it's temporary. You're conscious now, but billions of years ago, you didn't exist, and billions of years from now, you won't exist again. Consciousness is a temporary gift. The neuroscientist Christoph Koch has spent his career studying consciousness. In his work, he's documented how fragile and rare consciousness is. Even among animals, consciousness seems to vary. A dog is conscious differently than a human. A fish might not be conscious at all, or might be conscious in ways we can't understand. But somewhere, in complex brains, consciousness emerges. Here's what that means. Your consciousness, right now, is one of the rarest things in the universe. There are more stars in the universe than there are conscious beings. Conscious beings are rarer than stars. If consciousness is central to the universe's purpose, then preserving it, cultivating it, and expanding it becomes an imperative, not because of religion or philosophy, but because of physics, because of the structure of reality. Think of it this way. The universe has been working toward consciousness for 14 billion years. Stars died. Elements were created. Planets formed. Life evolved. Brains developed. And now, consciousness exists. And here you are, a conscious being. You're the end product of 14 billion years of cosmic preparation. The universe has handed you consciousness. What you do with it matters. Not because of morality, though morality emerges naturally from this perspective, but because consciousness is precious. Every moment you're conscious, you're participating in the universe's central purpose. Every moment you're aware, you're part of the cosmic story. This is actually liberating. It means that simply being conscious, simply being aware, is enough. You don't need to accomplish great things to have value. You don't need to become famous or rich or powerful. Your consciousness, your awareness, your ability to experience and witness, that's enough. That's sufficient. That's your contribution to the universe. In 1957, the poet and Zen Buddhist Gary Snyder wrote, "The most important job we have is to wake up." He meant it literally. Wake up. Be conscious. Be aware. That's enough. That's the point. The 12th mind-blown moment. Your existence has meaning, not because you achieve something, but because you're conscious. Your consciousness is central to the universe's self-knowledge. And that means you're not lost. You're not purposeless. You're not wandering randomly through an uncaring cosmos. You're part of the cosmos's own self-awareness. As you lie there, night after night, conscious, aware, thinking, feeling, you're participating in something ancient and vast. The universe, through you, is witnessing itself. The universe, through your consciousness, is experiencing itself. That's not a small thing. That's the deepest thing there is. And knowing that your consciousness is the universe knowing itself, changes how you relate to your own awareness. Your thoughts aren't just electrical impulses in your brain. They're the universe thinking. Your feelings aren't just neurochemistry. They're the universe feeling. Your awareness isn't just a side effect of complexity. It's the point. It's what the whole cosmic story has been building toward. So we've established that consciousness is sacred, that your awareness is central to the universe's purpose. But there's one more level to this. Understanding that you're made of the universe, that you're connected to everything, and that your consciousness is central to cosmic purpose means that how you treat others directly reflects how you treat the universe itself. Here's the final piece of the cosmic puzzle. If you're made of the same atoms as everyone else, if everyone is part of the same cosmic story, if everyone's consciousness is the universe experiencing itself, then when you look at another conscious being, you're looking at the universe looking at itself through another pair of eyes. This isn't spiritual. This is physics. You and I and everyone else are made of atoms that were all created in stars. Your atoms and my atoms have a common origin. They were once part of the same star. They were scattered in the same supernova. They've been cycling through the universe together for billions of years. In fact, because atoms are indistinguishable, because you can't tell one carbon atom from another carbon atom, there's a real sense in which you and I share atoms, not metaphorically. Literally. The air you breathe is air that others have breathed. The water you drink is water that others have drunk. You're quite literally exchanging matter with everyone around you. Think of it like this. Imagine you're a wave in the ocean. You think of yourself as separate from other waves. But you're all made of the same water, and the water that makes up you also makes up every other wave. In a sense, you're not separate. You're all part of the same ocean, temporarily organized into different wave patterns. That's what the physicist Alan Watts used to teach. He'd say, "You are an organ of the universe. You are a cell in the body of the cosmos, and the universe, through you, is looking at itself." The biologist Lynn Margulies spent her career studying how organisms are actually nested systems of smaller organisms. Your cells have mitochondria that were once separate bacteria. Your consciousness emerges from billions of cells cooperating. You're not a unified, separate thing. You're a community, an ecosystem, a collective consciousness. And that collective consciousness is connected to all other collective consciousnesses through shared atoms, shared history, shared cosmic origin. If everyone is the universe experiencing itself through different eyes, then harming someone else is harming the universe. Helping someone else is helping the universe. Loving someone is loving the cosmos itself. This isn't something you should do because it's morally right, though it is. It's something that follows naturally from understanding the structure of reality, when you really feel the interconnection, when you really know, in your bones, that you're made of the same stuff as everyone else, that you're all part of the same cosmic story. Compassion becomes inevitable. It's not a choice. It's an understanding. The Dalai Lama has spent his life teaching compassion. He says, if you want others to be happy, practice compassion. If you want to be happy, practice compassion. It's often interpreted as a spiritual teaching, but it's also a statement about the structure of reality. The reason compassion makes you happy is because harming others creates internal conflict between the illusion of separation and the reality of connection. When you feel compassion, you're aligning yourself with the truth of how things are. You're acknowledging the interconnection that physics reveals. The 13th mind-blown moment, you're not alone. You've never been alone. You're connected to every other conscious being through atoms, through history, through the shared cosmic origin. When you look at another person, you're looking at the universe, looking at itself. When you help someone, you're helping yourself. When you harm someone, you're harming yourself, not metaphorically. That's just how reality is structured, and knowing that, living with that awareness, is incredibly peaceful. It means you don't have to be afraid. You can't be fundamentally alone or separate. You're connected to everything. You're a part of a community that extends across the entire universe and the entire history of time. As you lie there, remember that the people you love, the people you care about, are made of the same cosmic material as you. They're experiencing the universe just as you are. They're the universe being aware of itself. Who's like you? And that means your love for them is literally cosmic. It's the universe loving itself through you. Retention hook. We've come a long way. We've traveled from the biggest scales of the universe, the stretching darkness, dying stars, black holes, to the smallest scales, quantum uncertainty, atoms, consciousness. And we've seen how it all connects, how you're made of it all, how your consciousness is central to it all. But there's one final revelation that ties everything together and shows you why. In the end, the universe is fundamentally peaceful. We've taken a 210-minute journey through the cosmos. We started with the simple observation that when you look at the night sky, you're looking at the past. Light from distant stars has traveled for years, centuries, millennia, to reach your eyes in this moment. We watch the universe expand and cool, slowly drifting toward a state of perfect peace. We saw how stars are born and die in beautiful cycles, creating the elements that make you. We learned about the stability of orbits, the tidal locking of moons, the mathematical perfection of black holes. We discovered that at the smallest scales, the universe is uncertain and free. We saw how quantum effects transition into classical order through We realized that the fundamental constants seem fine-tuned to allow consciousness to emerge. And we understood that consciousness is what the universe has been building toward for 14 billion years. And now, as we approach the end of our time together, it's time to ask, what does this all mean? How should this knowledge change you? Let me tell you what I've come to believe after studying these cosmic facts for years. The universe is peaceful because it's orderly, and it's orderly because it follows laws. This might sound obvious. Of course, the universe follows laws. But think about what this means. It means the universe is not random. It's not chaotic. It's not arbitrary. At every scale, from the largest to the smallest, the universe follows mathematical patterns. Einstein didn't just discover that gravity could be described as curved space. He discovered that the universe is fundamentally comprehensible. You can write down equations that predict how reality works. A school kid with a pencil and paper can calculate how long it takes for a planet to orbit a star, knowing only the distance and mass. That's amazing. That's profound. The universe is not incomprehensible. It's not irrational. It's beautiful in its mathematical regularity, and because it's regular, it's peaceful. Predictability breeds peace. When you know the rules, you can navigate with confidence. When you know the sun will rise tomorrow, you can relax. When you know gravity will continue to hold your planet in orbit, you don't have to fear falling into the sun. But here's what's even deeper. The laws don't feel imposed. They don't feel arbitrary. They feel natural. The same laws that govern stars govern atoms. The same mathematics that describes planets describes quantum fields. There's a unity underneath all of reality. A deep simplicity. Physicists call it elegance beauty. In 1963, physicist Eugene Wigner wrote an essay titled The Unreasonable Effectiveness of Mathematics in the Natural Sciences. He marveled at the fact that human beings, using only our minds and mathematical reasoning, could discover truths about the physical world. How is it that abstract mathematics, something invented by humans, accurately describes the universe? It's almost like the universe is made of mathematics. Like math isn't discovered but revealed. And if the universe is made of mathematics, then mathematics itself is peaceful. There's a certainty to it. 2 + 2 = 4. Always. The Pythagorean theorem was true 2,000 years ago. It's true today, and it will be true 1,000,000 years from now. Mathematics is eternal, and if the universe is made of mathematics, then the universe is eternal and reliable in that same way. Now, you might think that laws are restrictive. Laws limit freedom. And in a sense, that's true. The laws of physics limit what's possible. You can't fly by flapping your arms because gravity is too strong and your arms are too small. You can't walk through walls because atoms repel each other. The laws constrain what's possible. But here's the thing. Those constraints are also what make reality stable. If there were no laws, if everything were random and arbitrary, then reality would be chaotic and unpredictable. You couldn't exist. Your body is held together by electromagnetic forces following quantum mechanical laws. If those laws changed even slightly, you'd fall apart. The laws don't constrain your existence. They enable Italiano. Think of it like this. Imagine a river. The riverbanks constrain the flow of water. They prevent the water from spreading out randomly in all directions. And because of these constraints, the river exists. It has a clear, defined form. It follows a path, but that path is beautiful. The constraints enabled a form. Your life is the same. The laws of physics constrain what's possible. And because of those constraints, your existence is possible. You're shaped by laws. You depend on laws. And that's peaceful, because it means reality is reliable. The laws won't change. Physics won't suddenly behave differently. Tomorrow, the sun will rise. Your atoms will follow quantum mechanics. Gravity will hold your feet to the earth. You can count on it, and in that reliability, there's deep peace. Here's something I want you to internalize. You're not outside the pattern. You're inside it. You're part of the laws. You're not an exception to physics. You're an expression of it. Your consciousness emerges from billions of neurons following electrochemical laws. Your thoughts are patterns of neural firing following quantum mechanics and classical physics. Your emotions are biochemical cascades following laws of chemistry. You're not separate from the universe. You're the universe in motion. You're the universe following its own laws. And here's what's beautiful about that. It means you're safe. You're not a fragile exception to the rules. You're part of the pattern. The same laws that hold galaxies together, hold your molecules together. The same gravity that keeps planets in orbit keeps your feet on the ground. You're not an accident. You're an inevitable expression of the laws. Given the initial conditions of the Big Bang, given the laws of physics, given time, you're inevitable. Not just possible, but likely. The universe, following its own laws, generates creatures like you, conscious, aware, capable of wondering about the cosmos. The physicist Paul Davies wrote, "The odds against life existing by chance are so enormous that if life did begin by sheer accident, then we must be the only thinking beings in the observable universe." And maybe that's true. Maybe consciousness is extraordinarily rare. But that doesn't make it an accident. That makes it precious. That makes it the point. Now, you might ask, if everything follows laws, if everything is determined by physics, then how am I free? How do I have choices? This is one of the deepest questions in philosophy, and quantum mechanics gives us a clue. At the quantum level, there's genuine randomness. Outcomes are not predetermined. They're probabilistic. An electron can be in multiple states until measured. A quantum system can evolve in multiple ways. There's freedom at the quantum level. Your brain is made of quantum systems. Synaptic vesicles release neurotransmitters based on quantum events. Your neurons fire based on the collective behavior of billions of ions whose movements have quantum components. At the quantum level, your brain is not predetermined. It's open. It's free, but your consciousness arises from the averaging of billions of quantum events. From the bird's eye view, from the perspective of your thoughts and feelings, things look determined. Your feelings feel like they matter. Your choices feel real. And they are. Because even though individual quantum events are random, the statistical pattern is reliable. Your sense of self, your agency, emerges from that reliable pattern. It's like this. Imagine a large group of people voting. Each individual vote is unpredictable. You can't know how any one person will vote, but the overall result is fairly predictable. Democracy works because even though individual votes are uncertain, the aggregate is reliable. Your mind works the same way. Individual quantum events in your neurons are uncertain, but the aggregate emerges as your consciousness, which feels stable, coherent, and capable of choice. So, you're free, in a sense. Not free from the laws, you're constrained by them, but free within the laws. Free to think, to feel, to choose. The laws don't prevent freedom, they enable Italiano. They provide the stable structure within which freedom can exist, and that's peaceful. You're not predestined. You're not locked into one future. You have genuine options. Genuine choices. But those choices happen within a framework that's stable and reliable. One final thing we need to talk about. Death. We've spent this entire journey marveling at the cosmos, at consciousness, at your place in the universe. But all of this is temporary. You will die. One day, your consciousness will end. Your atoms will disperse. Your body will return to the elements from which it came. And here's the surprising thing. That's peaceful too. That's actually the most peaceful thing about the universe. Think about it this way. If the universe is constantly creating and destroying, constantly cycling matter and energy, then death isn't an exception to the cosmic pattern. Death is the pattern. Stars die, matter decays, consciousness ends, and new stars are born. New matter is created, new consciousness emerges. It's a cycle. It's eternal. You're part of that cycle. Your body will return to the universe. Your atoms, the same atoms that were in ancient stars that have been cycling through the cosmos for billions of years, will continue cycling. They won't be destroyed, they'll be released. They'll become part of something new. Think of it like this. Your body is like a library book. It's been checked out. From the library of the universe, you get to read it to experience life for a while. And then you return it. The book goes back to the library, where it can be checked out again, read by someone new. The book itself continues. It's not destroyed. It's redistributed. That's what happens to your atoms. They'll continue existing. They'll continue participating in the cosmic dance. They might become part of a tree, a star, another person, an ocean. They'll keep cycling. Your atoms are eternal, even if your consciousness is temporary. And here's the deepest part. The fact that you're temporary is what makes your existence meaningful. If you lived forever, nothing would matter. Every moment could be the next moment. Every experience could be repeated infinitely. But because you're temporary, because your time is limited, every moment matters. Every experience is precious. The fact that you will die, the fact that you have limited time is what makes being alive so valuable. You can't take it for granted. You can't postpone living. You have to live now, and that urgency, that awareness of finitude, is what makes life meaningful. The philosopher Martin Heidegger called this awareness being toward death. It's the realization that you're mortal, that your time is limited, and that this knowledge fundamentally changes how you should live. It's not depressing. It's liberating. Because once you accept that you're going to die, you're free to really live. So here's what we've discovered in this 210-minute journey. First, you're made of stardust. Literally, chemically. Every atom in your body was created in a star. Second, you're connected to everything else through this shared cosmic origin, the same atoms that make you make all living things. Third, your consciousness is the rarest and most precious thing in the universe. It's what the entire cosmos has been building toward. Fourth, you're not separate from the laws of physics. You're an expression of them. And because the laws are orderly and beautiful, you're orderly and beautiful. Fifth, you're free within those laws. You have genuine choices, genuine agency. Sixth, you're temporary. You will die. Your consciousness will end. And that's okay. That's peaceful. Because death is part of the cosmic cycle. Your atoms will continue. The universe will continue. And your temporary existence will have been real, will have mattered, will have been part of something eternal. Seventh, and finally, the universe is fundamentally peaceful. Not because it's empty or uncaring, but because it's orderly, mathematical, reliable, and oriented toward consciousness. The universe is peaceful because it follows beautiful laws. And you're part of those laws. You're safe. You're home. So now, as we come to the end of this journey, I want you to just lie there. Let yourself feel these truths. You're made of ancient atoms. You're connected to everyone and everything. You're conscious, and consciousness is cosmic. You're temporary, and that's okay. You're part of a pattern that's larger than you, older than you, more beautiful than you. Feel the weight of the bed beneath you. Feel your breath entering and leaving your body. That oxygen was created in a star. Those atoms entering your lungs have been cycling through the universe for billions of years. You're breathing in the cosmos. Feel your heartbeats. That rhythm, that pulse, is the same rhythm that governs stars, planets, galaxies. The cosmos has a heartbeat, and you're part of it. Let your mind settle. Stop thinking about problems, worries, things you need to do. Those things are small, and you're large. You're cosmic. You're part of something that stretches across billions of light years and billions of years. Your worries are real and valid, but they're also small compared to the magnitude of what you are. And in that recognition, that perspective shift, there's peace. There's the realization that you're held by gravity. You're held by atoms. You're held by the laws of physics. You're held by the pattern of the cosmos. You're not lost. You're home. And when you wake up tomorrow, remember, the sun that rises is the same sun that has burned steadily for 4.6 billion years. It's burned through your entire existence, and billions of years of existence before you. It will burn for billions more. That's stability. That's reliability. That's peace. The stars you might see on a clear night are ancient. Their light is ancient. They're looking at you from the past. Unchanged, eternal. They're reminding you that some things are stable. Some things last. Some things can be trusted. And most importantly, you last. Not your consciousness, that's temporary. But you as atoms. You as patterns. You as part of the cosmic cycle or eternal. You're part of something that doesn't die. The universe doesn't die. It evolves. It changes. But it doesn't end. It cools down. It slows down. It finds peace. But it doesn't disappear. And neither do you. Thank you for taking this journey with me. Thank you for being conscious. For being aware. For paying attention to the cosmos. Your consciousness, right now, is the universe knowing itself. And that's beautiful. If this video brought you peace, brought you wonder, brought you a sense of connection to something larger than yourself, it helped you sleep, helped you feel less alone, then please hit that subscribe button. Share this with someone you care about. Let other conscious beings know that they're not alone, that they're part of something cosmic, that their existence is meaningful. And I want to know, where are you right now? Are you still in the same place where you started watching? Has your perspective shifted? Drop a comment. Tell me where you are. Tell me what you're feeling. Tell me how the cosmos is treating you. We're all on this pale blue dot together, spinning through the darkness, and we're all made of the same stuff. Your comment is part of the cosmic conversation. Your voice matters.